Hey everybody, this is Larry. This is day 20th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Env type, why did they do this? That's not even like a referral thing. That's very weird. Alright, oops. Today's farm is 1658, minimum operations to reduce X to 0. Hope everyone's having a great week so far. New York is pretty nice today. A good time of the year, 70 degrees Fahrenheit during the day. What is that in Celsius? Like 15 or something like this? No, but like 16, 17. Very nice breezy day. So I'm kind of enjoying New York September for now. Anyway, let's take a look at today's farm. Let's see. Okay, you're given an integer array nums and an integer x. In one operation, you can either remove the leftmost or rightmost element from nums and subtract its value from x. Note that this modifies the array for future operations. Return the minimum number of operations to return x or reduce x to exactly 0 if possible, otherwise return -1. Okay. Okay, so I think there are a couple of ways to think about this. I mean, I think this is actually one of the problems where I think it would be more interesting if we didn't know its difficulty. I think the medium kind of gives it away a little bit, because I think back in the day I might have at least kind of maybe like I want the possibility of overthinking it. That's part of the difficulty sometimes is that you may come up with some crazy scheme just to realize that you don't need a crazy scheme. But those of you who kind of did daily problems way back in the day, they didn't used to have this format. But in any case, we don't have to kind of go in nostalgia. But basically the idea is, I think the idea is going to be this, right? So you can only take some prefix and some suffix. So there are a couple of things. So the way that I think about it is how can I brute force, right? And what I mean by that is by testing everything as possible. And like I said, you only need to take the prefix or the suffix, or some amount of prefix and some amount of suffix, right? It could be the entire way, but some amount of that. And here, the way that I think about brute force is, okay, let's say we take 0 element from the prefix, how many do we have to take from the suffix? Let's say we take 0 element from the prefix, how many do we have to take? Oh, sorry, did I say that already? If you take 1 element from the prefix, how many do you have to take from the suffix, right? So for example, if it's 0, then it would require the last 2. If and there are no negative numbers, right? Nope. If you have 1, you only need the last 1, right? If you take 2, you only need the last 1 as well. I mean, I say the last 1, but obviously 1 plus 3 is 9. You go to 5, so it's incorrect. But you would only take up to 1. You take 2, right? That adds to 5. And there are 2 ways to be honest. And these are the things where you kind of think about it and you explore it and you get the solution by the exploration, right? And not gonna lie, my initial thought was to use a suffix sum, which is prefix sum but going backwards, and then maybe have a lookup table so I could be like, there's 0, so let's look at 5, right? And then here's 1, so let's look at, here's 1, so then because x is 5, we only look for 4. The prefix is 2, so now you only look for 3, ... so forth, right? And that's fine. And that also will give you constant time per operation, so it'll give you probably linear time, linear space, or something like this, right? But then that is the benefit of kind of looking through it a little bit, is that you also realize that as we kind of increase numbers on the left side, on the prefix side, we tend to decrease on the right side, right? So because of that, I think you can kind of use 2 pointers in that way, one for the prefix and one for the suffix. So I guess 2 pointers means something else, and maybe that's a bad naming, but yeah. And this all predicates on the fact that x is positive, right? I mean, with 0, I mean it would be the same thing with 0. It's just that you could greedy it away because, well, you're trying to minimize the number of operations. But here, we're going to always be monotonic, or not even monotonic, we'll be strictly increasing. So yeah, cool. I think that's all I have for this to kind of get started. So yeah, let's actually code this thing then, right? So okay, so n is equal to nums, right? Oops. Best is equal to infinity for now. And then here, we'll start by, it has to have some suffix index, right? Is equal to n minus 1. Yeah, so then while, and then maybe like a current total is equal to 0, while current total is less than x strictly, then current total we add it to num sub suffix index, and then we move it to the left, right? And we need a n suffix index is greater than 0. Okay, right? And then after this condition ends, and this condition only ends if either suffix index is equal to 0 or current total is equal to x. So if current total is equal to x, then best is equal to min, best, and this is a little bit awkward, but n minus suffix index, right? Or is it off by 1? This is off by 1 because this is not inclusive. So let's actually the way that I wrote is a little bit awkward. Yeah, because we want it to be inclusive. So I think this should be fine. Yeah, okay. Right. And then yeah. I think there is something like if current total is less than x, then we return -1 or whatever it is. But I think that's true. But I think to keep it kind of stupid simple, we just do if sum of nums is less than x, then we return -1, right? There may be other ways of doing -1 just because, you know, like if none of the sum somehow adds up to x in some way, that'd still be true. Okay, so then now we have some prefix index is equal to 0, right? So then now current total we added to prefix index, and then while well, this should be nums of this anyway, but I would maybe actually rewrite this as a for loop for prefix index in range of n, right? And then while current total is greater than x, we subtract it from the suffix. There's also another thing though. This is a little bit yucky because prefix index can go over it. So we actually also have to be, yeah, so while prefix index is greater than or equal to suffix index, then current total, so that we don't double count. Though I think this is a little bit, is this off? No, I think this is fine. So if current total now is equal to x, then the math is a little bit yucky. So prefix index plus 1 is going to be the number on the prefix side, and then plus n minus suffix index on the suffix side. So this is, I guess parent on this doesn't change anything. And then we can return best, but if best is greater than infinity or equal to, really, then -1. I think that's the only thing. Which line is that? 27? Oh yeah, I did forget to check. Okay. I think I missed the case where basically the prefix is now bigger than the suffix index. So I think this is, well, this n suffix index is less than n, then we're good. Yeah. I think we need to do this here as well. And I think it's more cleaner to write it the other way, but I guess this case cannot happen, or this cannot be out of bounds because by definition prefix is not out of bounds. Okay. To be honest, very this is a lot of kind of kinky, yeah, not kinky. Well, maybe a little bit, but if you're into it, this is a little bit messy kind of code. So I'm not super confident. Very many places for potential of off by 1. So I'm a little bit worried. But because this is a daily and I'm lazy, so let's click a submit, YOLO, and see how that goes. Okay, good. 1268. Wow, apparently I solved this 3 other times. Don't remember it. How did I do previously? Ding ding dong. Oh, I did what I said I was going to do with the suffix sum, which to be honest is still like, I don't know. I feel like that's easier if I was doing it in a contest. I did it this way as well, prefix. So I have a prefix sum and then, yeah. Oh, this is cool. I guess this way, instead of trying to get the sum of the prefix and the suffix, I take that as the total minus the prefix and the suffix. So then now it is the 2 pointers to get the middle. That's actually, okay. Good job, Pass Larry. Didn't do it that way this time, but good job, Pass Larry. And this one, I used the table again. So okay, so apparently this is the first time I've used the pointer way. So that's kind of cool too. I mean, something new. Because all these, this is linear time and linear space. This is also linear time, linear space. Huh. And this is linear time, linear space. So this is the first time I've done a linear time, constant space. And yeah, that's all I have for this one. Let me know what you think. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.